Good afternoon to all of you. Welcome you guys. Very good afternoon to all of you. Welcome you all. Welcome you guys. Welcome you all. So I think we are live. So here, could you please confirm this audio video is clear or not? Could you please confirm whether this audio video is clear? We are live. So I hope all of you able to listen properly. So my audio video is clear to everybody. Fine. Chalo. So chalo, let's continue our discussion. So here the question series we are starting. So here we are going to discuss about the most expected questions for the GATE 2023. So 25 questions I will try to discuss, and I have framed the questions. It will almost each and every topic will cover. Fine. So now we are going to discuss about all the static electric field, magnetic field and electromagnetic fields based upon the previous year's analysis, and we are going to analyze the papers. Fine. So all of you try to follow, and if anybody want to follow this my courses and all, you can so click on this link, that is you can follow me in the Telegram channel. So in the Telegram channel you can search the BV Reddy GATE. You will get my groups. There you will get the short notes, DPP, everything आपको मिलेगा. चलिए हम शुरू करेगा. Let's start our discussions. And you do follow me in the Unacademy. So after completion of this class, the complete PDF I will share in the community. I will share it. The complete PDF I will share in the community section. I will share it. Chaliye, let's start our discussions. And another one big news thing here. So by the Unacademy to offer, this is one of the great opportunity to all of you. And so with this you can plan your preparation properly. The chance to get the 23% discount आपको मिलने वाला. You can able to get the 23% discount आपको मिलने वाला. So by using the code of BV Reddy. By using the code of what? BV Reddy, you will get the great opportunities आपको मिलने वाला. The personalized guidance from me, and then short notes, DPP, सब कुछ आपको मिलने वाला. And this offer which is valid for up to 6th only. Try to utilize these opportunities before going to expire. And so these are the ECN electrical, so ESC 2022 top rankers. And these are the new batches are going to commence for the GATE 2024. You can find the top educators team, you can find, right? So in this batch, so I'm going to start the digital electronics. I'm going to start from the January 18th onwards. You can follow me in this courses. To enroll for it, you can join the Unacademy Plus by using a code of BV Reddy, right? And these are the 2025 batches we are starting, and these are the USPs and key differentiators of this thing here. With this you can, this course what we are starting, that course will be helpful for this all type of PSUs, and so ESC, IRMS, and as well as as well as a ESC mains also available. So these are the courses we are starting for the GATE, ESC, IRMS, as well as a CSA mains also. You can find the top educators team, and you can have a look at now here for 2025. So these are the top educators you can find here. You can see, right? and these are the batches we are starting for the IRMS batch. You can see the educators, and so we are starting the new batches for the IRMS as well as the ESC so 2023 mains also, right? And so you can enroll for this GATE plus UPSC GS combo. So by using a referral code of BV Reddy, you will get a great discounts आपको मिलने वाला, right? Now, so these are the, on January 8th we have a all India mock test. So here all of you attempt this mock test. You can enroll for this mock test by using the code of BV Reddy. You will get it now here. So here we are discuss some expected questions. We'll discuss ना अगर is a similar type of problems अगर exam में मिला तो, so you can able to attempt. Okay. So here you can see this thing. अगर similar type of questions आया तो fine. The expected questions we are preparing now, right? And so with this all India mock test, you will get the scholarship also. 1 to 10 100% scholarship, 11 to 60 75%, 61 to 200 50% scholarship, 200 to 500 so 25% scholarship आपको मिलने वाला. Don't miss these opportunities. And here, so this Unacademy, so I have prepared one exclusively short notes for the electrical students, EMF short notes. I'll just show you the some of the glimpse of the short notes what I have prepared. So I have taken a lot of care I have taken so to prepare this short notes. Have a look at these short notes briefly, and the short notes everything complete I will upload after completion of the class in the community sections. You can able to download, you can able to access the short notes. These are the short notes I have prepared. Okay, so can have a look at now here how much care I have taken. So I tried my best to prepare this as a very neatly short notes. You can have a look at here. I hope all of you can understand. Right, this is the magnetic fields. You can have a look at here, short notes. Right, fine. So these are the Maxwell's equations, complete, fine. Chalo, let's start our discussion now here, one by one questions. Take down first questions. The most expected questions we are going to handle here. Take the first question. Given V equal to the given some vector and SC is the surface of a unit cube with one corner at the origin and the edges are parallel to coordinate axis. The value of closed surface integral of, here the value of closed surface integral of V bar dot ds is, now you tell me now here they asking to find, here they asking to find what, you tell me now here, closed surface integration they asking to find, that is closed surface integral of V bar dot n cap into ds, isn't it? Now as we know here, so what the ds is a vector quantity and the direction which is perpendicular direction. So here in general which we used to write it as ds is a vector quantity, that is ds bar I can say, and it has a magnitude which we used to write it as a ds, and the direction of surface area which is normal to the surface, right? So to indicate the normal direction we use one unit vector of n cap, where n cap is a unit vector normal to the surface. Okay, so generally which we used to follow, this is the way. Now so that what they given in this thing here. So now instead of writing this is separately ds and n cap separately, what I am doing is, by combining this thing here, I am simply writing this thing as a closed surface integration of what? V bar dot ds bar. All of you tell me. So this n cap is also included in the ds. Now you tell me, now here we have closed surface integration. So can we apply the divergence theorem? By using divergence theorem, what we can do, tell me now here, what is the divergence theorem? That is closed surface integration of, what I can say now here, A dot ds, which is given as what? Volume integration of del dot A into dv from the divergence theorem. So can we apply the divergence theorem now for here? So what is the divergence theorem, tell me here? I can say closed surface integration, which we can convert into a volume integration. Now tell me. And which is given as what? Volume integration of what? Del dot v bar into d. Now, so this is v vector is given. So v vector given, can you find the divergence of this vector? Tell me. Can I find the divergence of this vector? Tell me now, del dot v bar, which is given as what I can say here. So the divergence. So here this is the x component, y component, z component. So what I should do here? X component, I should differentiate with respect to x. What I will get, you tell me now, divergence. That is cos square y. And the second one, this the y derivatives will becomes what now? 0. And here the z derivative. So here what I will get, you tell me, which is equal to sine square y. Tell me cos square y plus sine square y, which will becomes what, you tell me now? 1. So that means we got the divergence, we got it as a 1. So the divergence value, which we can substitute here, volume integration of 1 into dv. So what I will get now? Integration of dv. What I will get now here? Volume of what? Volume of the given figure. What is the given figure? The given is a unit cube. What is the volume of a cube? As we know, volume of a cube, which is equal to a cube now. Here how much is a value? Unit cube, that means a value 1. So that means how much is answer? 1. Done all of you? Chalo, next problem. Enter, take the next problem. Given the vector, they given us like this. Now they ask him to find what is the b. That means the nature of the vector b, they ask him to find. See this thing here, what we can do. They given a vector, b bar is given, they ask him to find what is the nature of this vector b. Now you see this thing, if, as we know, if the divergence of a vector is 0, if the divergence of vector is 0, then that vector which is called as what? Then this vector which is called as a solenoidal vector. If the divergence of vector 0, then that vector is called as a solenoidal vector. Next, if curl of a vector is 0, if the del cross A, which is equal to curl of a vector, here the vector is given b now, so let us take the b only. So if the curl of a vector is 0, then that vector is called as a irrotational or conservative. Is called as what? Irrotational, or we can call this as a conservative. Now you tell me now here. Now you tell me now here from this what we can say. Now we need to verify whether the divergence is 0 or curl is 0. We need to verify this thing. So let us find out this thing here. The vector b vector, which is given as what here? This is y plus z into cos of xz into ax cap along x directions, and this x into ay cap plus x into cos xz into az cap. So let us find the divergence and curl. Let us find the divergence now here. That is del dot b. If we calculate now here, tell me. And this whole thing is an x component. Now this x component we should differentiate with respect to what you tell me now. X से differentiate करना पड़ेगा. Let's differentiate this x component with respect to x. You tell me what I will get. If I differentiate this thing here, y derivative 0. So what I will get now here? Minus z square into cos, that is sine of xy. Okay. Next. So here this derivative 0. Next, what I will get now here, this is cos derivative which is equal to minus sine. So cos derivative which will get it as a minus sine. Tell me how much will get, you tell me now here. And so this is, and thereafter this is minus x into what I will get now here, cos. So that is sine xy. Z derivative now here. So what I will get now here, x. So z derivative means which will come, x square will come here. So tell me now how much we'll get now here, del dot b. Is the del dot b which we got, is it 0 or non-zero? That is z square into sine xy minus x square into sine xy. Right, all of you? This is xz now. Sorry, this is what? xz, right? Right. Now you can see now which is 0 or non-zero. Is non-zero. So the divergence of vector which is non-zero means what you tell me now here, if the divergence is 0, that vector is a solenoidal. So from this what I can say now, this vector b is not a solenoidal now. So this is a non-solenoidal. Divergence is non-zero. Now thereafter what we can do, we need to find the curl, we need to find. So let us find the curl also. How we can find the curl of a vector? By using the determinant method. Now tell me all of you, del cross b. Now you tell me now, this is ax, ay, az unit vectors, and so tell me now del, so that is dou by dou x and dou by dou y and dou by dou z. And then tell me now here components along x, y, z directions. What we have? X components, what we have, tell me. This is y plus z into cos xz, next x, and this is x into cos xz. Now you tell me now here what I will get now here, x derivatives. So what I will get now here, AD minus BC we should do now here. Now this derivative which is 0 minus 0 minus ay. So tell me what we'll get now, ay. So x derivative, so we need to apply u into v rule, we should apply now. That is minus xz into what now here, sine of xz, and then what you tell me now here, plus cos xz. Next minus, so tell me now z derivatives, what we'll get here, minus 0, and which is equal to minus or minus plus xz into what I will get now here, cos of xz, and then minus cos xz. All of you tell me, plus AZ cap. AZ cap into what we'll get now? X derivative 1. So 1. So now you see this thing here. So finally we got the del cross vector B, which is a 0. Now tell me. Now here we got the curl of a vector is 0. If the curl of a vector is 0, then what I will call that vector is, tell me. Then that vector which is called as a irrotational or conservatives. So we can call this as a irrotational vector, irrotational or conservatives. Now from this, what's the option now here? We got the vector is a non-sinusoidal and but is irrotational. So kaun sa option, tell me? Option A. Done. Next one. The point charges the given Q1, Q2s are located at a distance apart. With regard to this situation, which one of the following statement is not correct? Which is not correct? Now, what they given, you see carefully. I have two charges now here. I have two charges. This is my Q1, which is given as 2 nanocoulombs, and the second charge Q2, and which is given as a 3 nanocoulombs, right? These are the two charges we have located. Now, so which are separated some distance. With regard to this thing, see the first statement is given. Now you see both are what type of charges? Both are same polarity, both are positive charges. Then what type of force between the two charges, you tell me? What type of force between the two charges? That is attraction or repulsion. Similar type of charges, that means which is a repulsion. Here they are asking to find which of the following statement is not correct statement we required now. The force is repulsion, that means which is correct statement now here. Next, coming to the C, the force Q1, Q2s are same in magnitude, yes or no? Whatever the force this Q1 will, so here Q1 will apply on the Q2, equal magnitude of force is there now, but opposite direction, yes or no? Now, so this force is this direction. If I say this is my F1 and this direction force which is equal to F2, right? Now the magnitude of F1 and magnitude of F2 both are equal, yes or no? The magnitude of the two forces are both are equal. So that means this statement is correct now. Same in magnitude. Magnitude are equal but directions are opposite directions. Next, the force on Q1, Q2 will depend on the medium which they are placed. As we know, according to Coulomb's law, what is the force between the two charges, you tell me? Which is given as 1 by 4 pi epsilon into what? Q1, Q2 by what? R square. Here what is this epsilon is a? Here what is the epsilon is a? Epsilon which is called as a permittivity of the medium. Epsilon is what? Permittivity. Permittivity of the medium. Now you tell me now here, to the different medium will have different values of permittivity. If we change the medium between the two charges, then the force will affect or not. So that means force depend on the medium. Yes, this statement is also size statement type. Now what is a false statement? You see this thing here coming to this is, now if we have a two charges, if I placed, here we have a charge, this is my Q1 and this is my Q2. Now, so if we place one more charge, this since both are positive charges only, right? Both are same polarity of charges, positive charges. If we place one more charge, capital Q, at a distance of small x from the Q1, if I say, then to keep the charges means, so there is no force means the to keep the system of the charges in equilibrium condition. So what could be the value of Q must be? The value of Q must be which is equal to, that is Q1 Q2 by square root of Q1 plus square root of Q2 whole square, and the charge which should be a negative charge. So this much of the charge must be placed in between the two charges such that the net force acting on the system must be 0. But here they has given this as a, if I substitute the values now here, how much I will get the Q value? So which is equal to 2 into 3 into what will get now here, that is root 2 plus root 3 whole square. This is a Q value we need to place, right? So which is not here now here, so that's why this option, this statement is wrong. That's why this statement is wrong. Is it fine, all of you? Done. Hello. So here, any further discussion required for you on this topic? Next one. 2-point charges 5 coulombs and minus 5 coulombs are located at the locations. Now they are asking to find the direction of the electric field at a point x, 0, z. Now, so what is basically the electric field formula, which is given as kq by r square into ar cap. If you see carefully, here we need to focus about the directions, right? Here we need what you tell me, directions only required, we no need of any magnitudes, right? Now as we know, here the charge has been located, here is one charge, here is another charge. Because of these two I need to find the electric field at this point. Now the distance from the first charge to this point P, if I call the distance is my R1 bar. Can I get this R1 bar? Distance means what we can say, final minus initial. So what I will get now here, that is xi, yeah, tell me minus 8 into j and plus z into k bar. Next R2 bar you tell me now here, which is given as xi plus 8j plus zk. Tell me all of you. And so these are, अगर आपने ध्यान से देखा तो here the magnitude of R1 and magnitude of R2 exactly equal होगा, yes or no? So that's why I am modifying this formula as this electric field E, which I am modifying this thing as kq by, this is AR is a unit vector which we can write this thing as R bar by, and I can say R cube. So here if you see carefully, this k by r cube is a magnitude. Those values constant, we can remove this thing here. So we'll concentrate on only directions, only we'll concentrate now. So इसीलिए मैंने ये इसको modify किया as what I did now, simply k1 into qr bar. I have modified as like this. K1 which is a constant. We need only directions only required now. Now you tell me the electric field at the point which is given as what we can say here. The sum of the two electric fields, I can say that is E1 plus E2. That is given as what? E1 plus E2. Now you tell me now E1, which is given as K1 into, first charge is a 5, that is 5 into what you tell me now, R1 is given as xi minus 8j plus zk. Next plus, so here now plus K1 into the charge is a minus 5 now, minus 5 into R2 value how much? Xi plus 8J plus Zk. Now can I simplify this thing here, which I will get it as this minus, so it will becomes 5K1 we have taken common, then it will becomes Xi minus 8J plus Zk minus Xi minus 8J minus Zk. Now you tell me now what happens now here. Xi will get cancelled, Zk will get cancelled. So finally what is the net field will get, you tell me now here. That is 5K1 into minus 16 into J. This is the electric field. We need only direction only required now here. What is the direction of this electric field, you tell me now here. Minus J means what? Negative y directions. Minus J means what? Negative y directions. Chalo, next problem. Take down. An infinite line with uniform charge density. Charge density is given, lies at x is equal to 2, comma z is equal to 4. Now they are asking to find the electric field at the origin. Now this is given as what, you tell me, line charge density. What is this? This is nothing but line charge density, royal value given. How much this value here? 20 nanocoulombs per meters. And where the line charge has been placed, they given x value 2 and z value 4. What are the y value? Y is a variable. That means the line charge which is placed parallel to y axis. Means where the charge has been placed, I can say x value 2, y is a variable quantity and z value is a 4. And due to this I want to find my electric field where at the point origin we should find. So we need to find where you need to find electric field at the origin. Now here, so here this is at this point we need to find, wherever you want to find the electric field, that point is a final point. That point is what? Final point. And here the charge lies now, this point is the initial point. This is what? Initial point. And the distance vector means final minus initial point. Now what is the electric field due to a line charge which is given as rho L by 2 pi epsilon mod rho into a rho cap, where a rho is a distance vector. So tell me now rho cap, which is a final minus initial now here, 0 comma 0 comma 0 minus this is 2 comma, since the line is parallel to y axis now, whatever the y coordinate here, that y coordinate will reflect here. All of you this thing. Here the line chart, this y value is a variable quantity. Whatever the y coordinate here, wherever you want to find, that y value reflect here. So tell me the row vector here. That is minus 2ax minus 4az. If we have any doubt in any of this thing, let me know. Fine. This is a row vector. From this we can get the magnitude or unit vector also we need to find out. So now tell me now here electric field. So what is royal value given? Royal value. So here 1 by 2 pi epsilon. How much this value here? So as we know here 1 by 4 pi epsilon naught. How much this value? Which is given as 9 into 10 power 9. 1 by 2 pi epsilon means how much here? 18 into 10 power 9 into royal value how much? 20 into 10 power minus 9. Right? And by magnitude vector, how much is magnitude? You tell me now. Square root of 4 plus 16, and the unit vector is what? Minus 2ax, and minus 4az, by what you tell me? Square root of 20 magnitude. And do simplify, get the answer. What will get? So simplify, get the answer. How much you will get? I think so you will get this option A will come. Check it, all of you. Minus 72 into az. So this is my final answer. Done. Next one. A ring placed along y square plus z square equal to 4. That is, what is a plane? It is a, what is that plane here? Y square plus z square equal to 4. Which plane is that? Tell me. That is nothing but yz plane. X is equal to 0 plane now. X is equal to 0 plane, which is nothing but yz plane. So you tell me now, electric field in case of this yz plane, in case circular ring, which is given as what? Rho L AH by epsilon into a square plus h square power 3 by 2, and the direction is normal, that is x direction, right? So which is normal to yz plane? X axis na, that's why ax cap. And they ask him to find the d na, not e. So as we know that d is equal to epsilon e, so from this we can get the d value. So d, which is given as what I can say, rho L AH by 2 into a square plus h square power 3 by 2 into ax cap. Done. Now let us simplify, substitute the values now here. We have this royal value. So this is royal value, how much here? That is 5 into 10 power minus 6. And A is a radius. So this circle radius is how much? You tell me, 2 na. And h is the distance from the center of the ring to the point, which is equal to how much here? 3. Center is an origin, and 2 into what we can say, a square plus h square, that is 2 square plus 3 square power 3 by 2, and the direction is what direction? X directions. Now can you simplify this thing? Can you simplify this thing, all of you? Simplify and get these values. That is point, do simplify, you will get this as 0.84 into ax cap microcoulombs per meter square. Check this thing, all of you. Done. So I hope you can able to do calculations. Try to simplify the calculations, right? Shall next problem? Infinite sheets of charge rho s1, rho s2 is given as like this. Z is equal to 1.5 and Z is equal to minus 0.5, right? Now they ask him to find electric field intensity for Z greater than 1.5 is. Now you see this thing here. Now if I call this is my z axis, I have a two planes now. What type of charges you can see now? These are the surface charges, right? One surface charge which is at where you tell me now here z is equal to 1.5 on this plane. Z value how much here? Z value, this is like a surface. Try to visualize properly. It is like a plate. This is my surface charge. Here this is my surface charge we have. So at where you tell me now here Z value how much? Z value 1.5 at 1.5 meters. So they has a charge. So this is given as rho s1. Okay, rho s. Now second one, where is other charge now? At minus 0.5. Tell me here. We have another charge. This is the another charge. Another surface charge here. So where Z is equal to minus 0.5 meters. And this will also will have same charge. You see magnitude of charges are same now here. That is rho s. Both having the same magnitude of the charges, isn't it? Now they are asking to find the electric field. Where you tell me? For Z greater than 1.5, that means somewhere here above this plate. So I hope you can able to visualize this thing here. So electric field. So here this is, you can see now, this is what type of charge here? This is the positive charge, and here this is the negative charge. And as we know, the electric field lines will move from the positive charge to negative charge. What are the field lines which are moving from positive to negative? They will be nullified on the negative charges. So here tell me what happens now here. Electric field above the two plates. How much here? How much the electric field above the two plates here? 0. Electric field below the two plates, which is also 0. The electric field above the two plates and below the two plates is 0. The electric field does not exist above and below. Where the electric field will exist? The electric field will exist in between the two charges only. In between the two charges only will exist, which is given as what you tell me? Rho s by epsilon. The electric field above the two plates 0, below the two plates is also 0. They are asking to find above the two plates now. So what is the option now? Tell me. Above the two plates means for Z greater than 1.5. That's why the electric field above the two plates is what? 0. Okay, fine. And this is the way to analyze analytically. So mathematically, if you want, what we can do here? What is the electric field due to surface charges? Electric field due to surface charge with the formula which is given as rho s by 2 epsilon. What is the formula here? Rho s by 2 epsilon. Electric field due to surface charge, and the direction was given by En cap. What is the En cap? Is a unit vector normal to the surface. Fine. Now if you see the first charge, if I call this is my charge 1 and this is my second charge, I want to find the electric field at a point because of the two charges. What is the electric field E1, you tell me? Which is given as rho s is how much? That is 50 epsilon naught by what? 2 epsilon naught into what I can say En. What the En is a unit vector normal to the plane. So this is my surface charge we have, and here is this is my z axis. And you tell me which is perpendicular to my surface charge. You tell me z axis which is perpendicular to my surface charge, isn't it? So the unit vector, and the point lies above the charge now here. So that's why which we can say this is plus Az cap. Next, and we'll find the electric field due to second charge. What is the electric field due to second charge? You tell me now. E2, which is given as the second charge is a negative charge is given now. minus 50 epsilon naught by 2 epsilon naught into En. So this, for the second charge, this point lies above only na, that is, so that's why it is plus Az. If I add these two here, the total electric field, what I can say now, tell me, sum of the two electric fields now here, E1 plus E2, the vector sum of the two fields. So as a result, what is the electric field, you tell me now here, which is equal to 0. Above the two plates, the electric field is 0. Is it fine? Chalo. Next one. Which of the following statements about the electric field lines associated with the electric charge is false? Which statements are false statement we required? Okay. Now you tell me the first one statement, what they given. The electric field lines either be a straight or curved. Yes, electric field lines either is a straight or curved shape. And electric field lines form a closed loop. So this is completely wrong. Electric field lines never form a closed loop. What is the electric field lines nature, you tell me? If we have a positive charge and the negative charge, if we have positive charge and negative charge, now how the nature, basically electric lines which will be straight lines like this, they will move from the positive to negative charges like this. Positive charge to negative charge, they can be straight lines or maybe a curved lines. The electric line will start from the positive charge and they will terminate on negative charges. But the electric lines cannot be in a closed form. Next one, electric field lines begin on a positive charge and end on negative charge. That is also correct statement now. And electric field lines do not intersect. Yes, electric field lines are never intersect. So which option is false, you tell me? Electric field lines forms a closed loop. Electric field lines does not form a closed loop. Next one. A 100 microcoulombs of point charge is located at the origin of a Cartesian system. Determine the electric flux through the square. Through the square, mod x lies between less than 1. So this value mod x less than 1 means x limits, what we can say here, minus 1 less than x less than plus 1, and minus 1 less than y less than plus 1. These are the limits for x. Now tell me x and y, and here z value is a constant. Z value how much? Z value is a constant. Now you tell me now here. Now how it could be either. All of you listen carefully. If I consider this is my z axis. Consider this is my z axis. Now here at this location, here we have z value equal to 2. Z value 2, so we should maintain the z value must be constant. We should maintain, now tell me. We need to maintain the z value must be constant. हाँ ना बोलिए. Z value maintain constant, x value can changes from minus 1 to plus 1, y value can changes from minus 1 to plus 1. So that means I can move constantly like this now here. X value, let us consider vertical is x axis. Consider this direction. This is x is from minus 1 to plus 1. And I can move parallel to y axis also. Y can be from where to where, you tell me? Y can be minus 1 to plus 1. So it could be like this. Now tell me, x value minus 1 to plus 1 and y value also minus 1 to plus 1. So then we can form the square shape like this. Try to visualize a square. Right, here the z value how much, you tell me? Z value it is 2. Right. Now, so what I am doing is, This is the origin. Now what I am doing is at exactly at z is equal to -2. Z is equal to -2. We'll try to form the another square like this. Here this is z is equal to -2. If I call, I am trying to form the another square like this. I moved parallel to x-axis as well as parallel to y-axis. I have moved. This is another square I have formed. Now let us try to form the other squares. Now here one closed figure, closed cube. Let us try to form. For this, I have formed the shape like this. Now if I have formed like this, here we have a charge is present here, Q. Now you see this thing here. Now where is the charge lies now? Charge lies complete inside my cube, you tell me. Then the charge will lies completely inside the cube, right? So can you tell me what is the amount of flux leaving from the cube? Then we can form a cube. We can form now here by closing all the things now here, all the shapes, the equal square. So can you tell me what is the amount of flux leaving through my cube? You tell me. That is the total charge. Yes or no? According to Gauss law, the flux is equal to Q enclosed, isn't it? Now you see this thing here, to get the cube, so how many sides we have required? You tell me. How many sides we have? How many surfaces are there? It has a 6 surfaces. It has how many surfaces? 6 surfaces. Now if you see carefully, now the total flux leaving from the all the surfaces, which is equal to Q. But in the problem they ask him to find x lies between -1 to +1, y lies between -1 to +1. So here they ask him to find the flux leaving through, what you tell me, the flux leaving through this side they ask him to find now, isn't it? They ask him to find the amount of flux leaving through this side, isn't it? This flux they ask him to find. So here the flux leaving through the 6 surfaces, which is equal to Q. Now what is the amount of flux leaving through the all the surfaces? I can, one surface means how much we can say here, that is equal to Q by 6 hoga na, tell me. The how many flux lines will crosses through my this surface, single surface, which is equal to Q by 6, I can say. So that's why what I will get now, my flux, which is given as how much the Q value, which is equal 100 by 6, which is given as what now here, 100 by 6. So what's the option, tell me now here? So option D. बहुत बढ़िया, isn't it all of you? The amount of flux leaving through one side, which is equal to what you tell me now here, Q by 6. Next one. Let D given, find the total charge enclosed within a closed surface defined as like this. Okay. Now they given the electric flux density is given. So from the Gauss law, what we can say, tell me? The flux, which is equal to closed surface integral of d dot ds, and which is equal to q enclosed, and which is equal to volume integration of rho v into dv, isn't it? So this is my Gauss law now, tell me. So flux is equal to q enclosed, which is equal to closed surface integral of D dot ds is equal to rho v into dv. Now they given d value given, they ask him to find the flux or q enclosed. Both are same only na. So that means flux which is also equal to q enclosed. So that is given as what you can say here, closed surface integral of d dot ds. Now here we have a closed surface integral. Can I apply the divergence theorem? We can apply the Gauss divergence theorem. By using a Gauss divergence theorem, so my flux, and which is given as no, so here D and E are different. So where E, which is called as a electric field intensity, this is called as a electric field intensity, and the D is called as a electric flux density. D is called as a electric flux density. And so here where E depends upon the medium, here this E depends on medium, depends on medium, but D independent of medium. And the relation between D and E, we have a relation between these two here, that is given as D is equal to epsilon E. D equal to epsilon E. E depends upon medium, but D is independent of medium. D is equal to epsilon E. Now this is Q enclosed, which is given as what? We have a closed surface integral. Can we apply the divergence theorem here? By using divergence theorem, closed surface integral which is converted to a volume integration na? And which is given as del dot D, del dot D into dV, del dot D into dV, right? So they given D value, so you can see the D value given now here. So here D value which is given as what? 4x cube into ax cap plus 3xz into ay cap plus x square y into az cap, that is nanocoulombs per meters. Now we need to find the divergence. We should find now here, that is del dot D, divergence in the Cartesian system. Tell me, I should differentiate this x component with x na, that is 12x square, and the y derivative 0 here, z derivative this term 0. So that means del dot D which is equal to 12x square. So that means my flux which is given as Q enclosed, which is given as what? Volume integration of what? So that is 12x square into dv means dx, dy and dz, dx, dy, dz. So the limits are given x, y, z, all the limits are 1 na? So here what we can say, this x limits, the 12 is a constant, x limits are what now here? 0 to 1, that is x square into dx, and y limits are 0 to 1, so that is dy, and z limits also 0 to 1 only na, into dz. So let's simplify and get it. 12 into what I can say here, x cube by 3, limits 0 to 1. So this is 1 and this is also 1 only na. So finally what I'll get now here, 4. 4, this units are nano, so that's why nanocoulombs. So this is the flux as well as charge also now. Now this flux, and that is also equal to Q, and which is given as what now, tell me, 4 nanocoulombs. Now what they are asking here, find the amount of electric flux passing through the closed surface and also indicate whether the electric flux is entering or leaving. So what is the flux, you tell me? Positive flux. Positive flux means what now? Entering or leaving? Leaving. Positive flux is positive now. So we can say this indicate this is a leaving nature. If the flux negative means which is a entering nature. Next one. Consider a uniform sphere of charge density given as rho naught. Charge density rho naught. Radius is given as a B centered at the origin. Now they are asked to find the electric field at a distance of r, where small r is less than B means inside they are asked to find. Now I have a sphere. So this sphere having a, this sphere will have a charge. What type of charge it will contain? Volume charge. It has charge density which is given as rho naught coulombs per meter cube. Now, so they are asked to find the electric field. Electric field, where you tell me now here, at a distance, this is center. So at a distance of small r from the capital R. This is small r. So what is the electric field formula, tell me? Where E, which is given as 1 by 4 pi epsilon according to Gauss law, into what you tell me now, Q enclosed by R square. Q enclosed by R square. Where what is a Q enclosed? What is the Q enclosed? Is a charge enclosed by the Gaussian surface. Here this red circle is there now. This is the Gaussian surface. Red circle is what you tell me? This is what? Gaussian surface. We need the charge up to my Gaussian surface. This part of charge we required, isn't it? Now you tell me now here, how we can get the charge now here? So the density which is a rho v, and we should multiply the volume of this part now. How much this volume of this part is? 4 by 3 pi. Radius of this part is how much, you tell me now? R now. That is 4 by 3 pi r cube. Now substitute these values in this formula E, which I will get it as 1 by 4 pi epsilon into what now, tell me now? Rho v, 4 by 3 pi r cube by small r square, where rho v is given as rho naught is given now. So this density is given as rho naught in the problem, right? Now let's substitute the values, get it now here. 4 pi will get cancelled. Finally how much will get here? That is r rho naught by 3 epsilon. So this is the electric field. Done? Next one. Given the potential function in the free space, they are asked to find the electric field at the given point 1, 2, 3. What is the relationship between the electric field and potential? The relationship between electric field and potential, which is given as E equal to minus del V. What is the relation is given as E equal to what? Minus del V. Now, so we need to differentiate this thing now here. So this is E. So the gradient now here, which is given as minus of what we can say, dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou z into az. Now let us find the electric field E, which is given as, so we need to differentiate now x derivative, what I will get now, minus outside. So what are the x derivatives are? We have 1 plus y, 1 plus y into ax cap plus y derivatives, what I will get to tell me now here, which is equal to minus 1 plus y derivative plus x into ay cap, and the z derivatives, what will get now here, 2 into az. Now we can, the given some point is given us, substitute the given point, which is given as minus of, what I will get to tell me. So here y value 2, so which is equal to 3ay minus, what will get a x value, so this is 0 into, this is ax now. So 3ax 0 ay, and this is minus 2az. So you tell me the option D. Done. Next one. An electric dipole moment is located at the origin in free space. In free space, whose expression is given as like this. They given a dipole moment is given. Now they ask you to find the potential at a point. At where you want to find the potential here? This is the point. At this point, so where the dipole is located now here? At the origin. Now can you tell me the distance vector, which is given as, the point is a final point, which is given as 2ax plus ay plus 5az. This is a r bar, isn't it? Now what is the potential to the dipole, you tell me. The potential to the dipole, which is given as V, which is given as 1 by 4 pi epsilon, 1 by 4 pi epsilon into, this is P bar dot R bar by R cube. This is the potential due to the electric dipole. This is the potential due to the electric dipole, where this R is the vector here. Now tell me now here V, which is given as, I will write here. So the V, which is given as, tell me, 1 by 4 pi epsilon means 9 into 10 power 9. P dot R, what is the dot product between this thing here, which will get it as 4 plus 1.5 plus 15, okay, into 10 power minus 9 by what now here, R cube. What is the magnitude of R, you tell me first of all, which is the square root of, what I can say, 4 plus 1 plus 25, that is a 30. So means, which we can say 30 power 3 by 2 now. 30 power 3 by 2. Now simplify and get this value. So see how much you will get the answer. So this 10 power minus 9, 10 power plus 9 will get cancelled. So this is 20. So what we have, this is 9 into 20.5, right? 20.5 by 30 power 3 by 2. So tell me how much will get, you see. Simplify, you will get the answer as 1.12 volts. Do check the calculation एक बार. Then next one. The potential at the centroid of an equilateral triangle of side given root 3 times of r due to 3 equal positive point charges is. Right. Now here we have 3 equal point charges. We have plus q, plus q, plus q are there. Okay. Now, so this distance which is each side given as a root 3 times of r. Now, so since we can say now the potential is a scalar quantity, the potential at the centroid because of all this, which is given as sum of all these three, which is scalar quantity. We can simply add them. Since the magnitudes are equal, which we can say this as a potential, which will be 3 times of potential caused by one charge, I can say. Since the magnitudes are equal, charges are equal, and this distance, so all these distances are equal only, na? I need to find this distance, centroid, this distance, and these distances are equal, isn't it? Now, here what we can say now here. So how much this distance you tell me now here. This distance which is given as root 3 by 2 into r, and this angle is a 30 degrees. I need this distance is required. If I call this is a d, tell me now here what I can say here. So cos 30. If you have taken a cos 30, which is given as what? Root 3 by 2 into r by d. So cos 30, which is equal to root 3 by 2 only, na? That is given as root 3 by 2 into r by d. So that means d equal to r. So that sees d is equal to what? R. Now what is the potential due to all the three charges, which is given as 3 into 1 by 4 pi epsilon and q by r. Distance is r, na? K q by r potential. So the option which is 3. Next, two isolated spherical conductors have radius given 6 and 12. They have charge, initial charges they have given. Now these are connected by a conducting wire. Then the common potential they ask me to find. Right, I have two conducting spheres. I have two conducting spheres we have. Let us say this is the sphere 1, this radius I am calling as r1, the charge is q1, and this radius is r2 and the charge is q2. These are the charges we have. Initial charges given as what now? This has a 12 microcoulombs, this has a minus 3 microcoulombs. Initial charges. Now you tell me now here, once they has been connected by conducting wire, see then what happens? Then the charge will start flowing from one conducting sphere to other conducting sphere until the two potentials will be same, na? Until the two potentials are same, charge will distribute one to other. Now if you see what is the total charge in this spheres now, q1 plus q2, q1 plus q2, which is equal to, if I call this as a qt, the total charge on the spheres, initial charges, which is equal to 9 microcoulombs. After reconnecting by conducting wire also, the equal amount of this amount of charge only. But one conductor charge will flow from one to other until the potentials are same, isn't it? After the interconnection, the charge I am calling it as a q1 dash. The charge I am calling this as a q2 dash. Then the potentials of these two conducting spheres must be equal. V1 is equal to V2. So can you tell me now what is a V1? V1 and V2 must be equal until the potential same, the charge flow will takes place, which is given as what? K. Q is what now? Q1 dash by radius is R1, which is equal to K Q2 dash by R2. Now you see this thing, what happens now here? Q1 dash by Q2 dash, and which is given as what you tell me now here? R1 by R2. Q1 dash by Q2 dash, which is nothing but what you can say? R1 dash by R2. These are the charges. These are the charges we have now. Tell me. Now, so what about the total amount of charge to remain same hoga na? Q1 dash plus Q2 dash. So here law of conservation of charges, it should be equal to Qt only. Whatever initial charge, same charge will maintain law of conservation of charges. Now by using this relation, can we apply the division rule? Q1 dash, if I call Q1 dash, which is given as what you tell me now? R1 by R1 plus R2 into the total charge, like our division formula. So what I'll get now here? Q1 dash now by the division rule, R1, which is equal to 6 by R1 plus R2, 18 into Qt. How much the Qt value here? This is 9. So from this, what I will get now? Q1 dash here, which is equal to 3 volts will, so 3 coulombs will get now, which will get it as what? 3 microcoulombs. Now this is what now here? Charge on the first sphere. Now with this, they ask you to find the common potential. So V1, how much here? That is K Q1 dash by R1. Tell me now here how much it is now. K value how much here? That is 9 into 10 power 9. Q1 dash, how much is value? 3. So which is given as 3 into 10 power minus 6, which is equal to 6 into 10 power minus 2. And do simplify, get this value. How much you will get? So nearly, I think so, 4.5 into what? 10 power 5 volts. Check the calculations. Done? Next one. If force with the plates of the capacitor charge given, so area given as A, attract each other. The force between the two plates of parallel plate capacitor. Now you tell me now what is the force now here? We have two conducting plates are there. If we have two conducting plates, so one is a positive plate, one is a positive charges we have given, and the second one is a negative charges, right? So then tell me now what is the force between these two here? Attractive force. We need to find the force now here. Now between these two here, this will having a charge of rho s, this will having a charge of minus rho s. Now what is the force between these two charges, which is given as what we can say? This is Q into E. We are finding the force on negative plate due to positive plate, which is given as F, which is given as what we can say here? Q means rho s is the charge density, which means what we can say? We can write this as and so here, so charge means what we can say? This is rho s into A, we can write now, surface area, into E. What is the E? Is the electric field. What is the electric field due to at this location, which is given as rho s by 2 epsilon, rho s by 2 epsilon. So the force which is given as what will get? rho s square A by 2 epsilon, now tell me. Now this charge, now multiplying and dividing with A, then it will becomes 2A epsilon hoga na. Then the force will becomes what now? Rho s into A, which is nothing but Q square by 2A epsilon. This is the force between the two plates of a parallel plate capacitor. Now you tell me now how the force will depends. You tell me it is directly proportional to the square of the Q square and inversely proportional to the area. So 2 and 3 are correct. Next. Sorry. 70. Yeah, the two homogeneous isotropic dielectric media with the dielectric constant given like this. Epsilon R1, epsilon R2 given. They given that here. So this problem comes in the boundary conditions. We have two mediums are there. One is xy plane. Xy plane means what plane is a z is equal to 0 plane. Z is equal to 0 plane. Now if I call, you see z is equal to 0 plane, and the left side which we can say z less than 0, and right side I should call this as z value greater than 0, right? And this I am calling it as a medium 1, and this is a second medium, isn't it? In the medium 1 they given that epsilon 1, which is given as what? 3 times of epsilon naught, epsilon 2, which is given as 2 times of epsilon naught, right, all of you? At a common point, so here electric field E1 given, so here this E1 will contain the tangential components and normal components. Can you tell me here? So this is what I should call now. This is a z is equal to 0, this is called my boundary now. Z is equal to 0, this is my boundary. So I need to get what you tell me now here. Now I need to get the what are the normal component, what are the tangential component. If you have taken this line here, this line is which is nothing but what axis? Z axis. And which is perpendicular to the boundary, tell me now. Z axis is perpendicular now. Can you tell me what are the tangential components and what are the normal components for here? So what are the tangential components? Normal components are Z axis is a boundary now. So all the Z components comes under normal components. So that means E1n, which is equal to what you tell me now here? Minus 4 into AZ. Can you tell me now E1t tangential components? Remaining are the tangential components now, which is given as AX minus 5AY. Now according to boundary conditions, what are the boundary condition we have? Boundary condition, tangential components of electric fields are continuous now here, according to boundary conditions. And what are the boundary conditions you tell me now here? E1t, which is equal to E2t. So tangential components of electric field intensities are continuous. So from this I can able to write the E2t, which is same as E1t. That means what I can say? AX minus 5AY. And what are normal components? You tell me normal component boundary conditions. Yeah, so that is D1n minus D2n, which is equal to 0. Why? Because rho s value 0 now, there is no surface charge density. D1n is equal to D2n. So which we can write it as epsilon 1 into E1n, which is equal to what I'll say here? Epsilon 2 into E2n. So now you simplify this thing here. Epsilon 1. How much the epsilon 1 is, which is equal to epsilon 1 value 3. So that is 3 epsilon naught into E1n, which is equal to minus 4AZ, and which is equal to what I can say here? Epsilon 2 means 2 into we should get the e to n we should get. From this, can you tell me how much this e to n value? E to n, which is equal to what you tell me now, minus 6 epsilon 2 into epsilon naught also, no? 6 az, isn't it? So from this we can write my e2 vector as what you tell me. So which is given as e2 vector is ax minus 5ay minus 6az. Now these are the k1, k2, k3. These are k1, k2, k3s we have now. K1 value how much here? So this is k1 minus k2 plus k3. So which is equal to what you tell me? 0 now. So the answer is 0. Done. Next one. Yeah, magnetostatics also will do. They given the V is given as like this is a solution of Laplace equation. They ask him to find the value of K. Now they ask him to find the value of K. Now you tell me now here. So this is the Laplace equations. What the Laplace equation is a del square V which is equal to 0. This is the Laplace equation. Now this is the solution for this V solution of this Laplace equation means this V value satisfy this equation na del square equal to V. So it is a Cartesian system. Now tell me now what we can do. So that is the dou square V by dou x square plus dou square V by dou y square plus dou square V by dou z square, which must be equal to 0. Now let us see the carefully. I think better we'll shift to the next page. It is thoda lengthy hoga na. Now tell me now here first derivative we'll do here. Tell me the first derivative here. What I will get now here? Dou by dou x of. Tell me first time derivative x derivative na sin hx, which is equal to cos hx na here. Cos hx into cos of ky into e power pz. Next y derivatives. Dou by dou y of what I will get now here? Cos ky means what now? Minus k into cos hx into sin ky into e power pz plus dou by dou z of. So what I will get now here? Cos, which is equal to cos hx and cos ky, and the z derivative means p into e power z na e power pz, that is 0. One more time derivatives. So cos hx is what now here? Sin hx only na into cos ky into e power pz. Next what will get now here? Minus k square into cos hx into cos ky into e power pz plus, now z derivative will get the p square into cos hx cos ky into e power pz, which is equal to 0. Check this thing all of you. Now if I take out the sin hx into cos ky into e power pz, we have taken common, that is 1 minus k square plus p square will come now, which is equal to 0. To satisfy this thing, this is nothing but basic potential V now. So this cannot be 0, means this term has to be 0 now, tell me. So means what we can say, 1 minus k square plus p square, which is equal to 0. So that means k square equal to 1 minus 1 plus p square. So finally k value how much you tell me? That is square root of 1 plus p square. Done. 1 plus p square, option B. Next one. A circular loop and a rectangular loop both are carrying the currents, okay, in the same direction as shown in the figure. The radius of the circular loop to have a magnetic field at the center of the both are equal. So we need to find the value of R so that magnetic field at the center both are equal. So in case of, if I call this is first one and this second figure, for the circular sections, magnetostatics, oh, you are talking about the theoretical classes you are asking, huh? Yeah, theoretical classes we not yet done in the magnetostatics. So I'm waiting for the approval from Unacademy team. Once they given the approval, I will do that one. I'm waiting. I didn't complete it. So theory not covered. So magnetic field because of circular section, which is given as, remember this formula H for the circular arc, I can say. For the arc at the center, which is given as, H is given as I by 2r into theta by 2 pi. This is the magnetic field due to the circular arc. Okay. And for in case of rectangular, so some polygon. For polygon, the magnetic field which is as H. For this polygon, n-sided polygon, n equal sided polygon, magnetic field is given as Ni by pi d into tan pi by n into sin pi by n. In special classes I have completed here. If you want, you can check in my profile, you can get. In special classes I have completed. So whether we can do it or not, so we don't know here, that's a reason. So if we can able to follow special classes, you can get the complete sequence, you can आपको मिलेगा. Ni by pi d into tan pi by n into sin pi by n. Now for the circular arc, so here completely magnetic field, if I call H1, which is given as, tell me, I by 2r into complete theta is 2 pi na, complete circle. So that's why which is given as, tell me now here, I by 2r. And for this thing here, this in this case, how much is n value, tell me how many sides are there? 4 sides. So that means in this case, if I say H2, which is given as 4I by pi d into what now, tan, so this is what now, 45 now here, and this is sine, this is also 45. So tell me how much will get the H2 here? H2, which will get this as 2 root 2 I by pi d. 2 root 2 I by pi d, this is my H2 and this is my H1. Now, so here they are saying that H1, H2s are equal, they are saying H1 equal to H2, they are saying, right. So now you tell me now here h1. How much the h1 here? I by 2r, that is given as I by 2r, which is given as 2 root 2 I by pi d. D value given as 2 given now, which is given as 2. Now simplify, get it now here. 2 will get cancelled here. So I will get cancelled here. What I will get this r now here, tell me. R is equal to 2 root 2 by pi. Check this thing all of you. This is my r. Next one. So a magnetic field B exists at a point if a test charge moving with a velocity v given experiences no force at a point, at certain point. The electric field at that point is. Now the force acting on a charged particle under the effect of both electric and magnetic field, which was given by the Lorentz force equation, which is given as Lorentz force equation, which is what? Q into E plus V cross B. These are Lorentz force equations. They are saying that the charged particle does not experience any force. Charged particle does not experience any force mean the total force acting on a particle must be 0 now. The force 0 means what I can say now, this is E, which is equal to minus of V cross B, right? And that means E, which is given as B cross V. So that is, which is given as E is equal to B cross V. Now let us find this thing here, the cross product here. So what I will get now, B cross V. So which we have, this is I, J, K. And the B is given as 1, 2, minus 4. Velocity. So V0 we have taken outside common. So that is 3, minus 1 and 2. Now let's expand this thing here. V0 into what I can say now, this is I into what we can say, AD minus BC, that is 4 minus 4, minus J into what I can say here, 2 plus 12 plus K into what, minus 1 minus 6. So that is finally E, which is given as what, to tell me, minus 14 V0 into J minus 7 V0 into K. So what's the option, tell me now, simplified? Option B. Next one. The magnetic field is given as like this. Now they are asking what should the function. If any vector is a magnetic field, it has to satisfy the condition, that is, the divergence of a magnetic field must be 0. Here the A is a magnetic field, they are saying na. So the divergence of magnetic field must be 0. This is the condition, isn't it? The divergence of magnetic field is always 0 only. Now see this thing here, let us find the divergence of this vector and we'll equate it to 0. So what should be now here, that is 2xy plus z square, and this is what now here, we should differentiate now here, dou f by dou z, which is equal to 0. Now you tell me now here, dou f by dou z, which is given as minus 2xy minus z square. To get this function f, I should integrate with respect to z now. Then it is my 2xyz minus z cube by 3. This is the my function. Done. Next, the circulation of H around the closed contour C shown in the figure is. They ask me to find the circulation. Circulation means what you tell me now? Closed line integration of H dot dl. Closed line integral of H dot dl, which is equal to 0. This thing they are asking to find circulations. Now you see this thing here. So they given the path, arrow given as a path direction is given now. So this is the arrow direction is given path directions. We need to be see carefully. Current is upwards. You tell me now here. Now, so here if the thumb is the current direction, fingers are the magnetic field. If both are same direction or not. So my actual magnetic field and path both are same now. If this magnetic field direction and dl direction both are same direction, the product is a positive. If both are same, then product will becomes what you tell me now, positive. Now you see in this case magnetic field, this is a magnetic field directions and this is given as a path direction dl. Both are same direction now here. So then which will get this thing as what you tell me now here, positive. How much, which is a 3i. Now for this case you see this thing here, this is a path. Now you tell me now current is downwards and path and field both are same direction now. That's why which is equal to plus 2i. Next, current is downwards, path is opposite here. They given this is the path, but actual magnetic field is this direction now here, opposite direction. So that's why which we have minus I. So then how much this value finally 5i minus I. So which is equal to what you tell me now, 4i. This is answer. An infinitely long wire carries a current. They given 2 amperes in the positive z direction. Find the magnetic flux through the loop. Now they given the plane is, which plane you tell me now, rho value changes, z value changes. Cylindrical system, rho comma phi comma z, right? Here the phi value they given as a constant which is not changes. Rho value changes, change in length along rho direction, we can say this as a d rho. Along z direction change in length, we can call this as a dz. So what I can say, ds now surface area, which is given as d rho into dz, where the rho limits are 0 to, rho limits given 2 to 6, z limits given 0 to 4. And what is a magnetic field due to infinite length conductor? H, which is given as what we can say, tell me magnetic field, that is given as I by 2 pi rho into a phi. This is a magnetic field due to a infinite length conductor. So this is, from this we can get the B now. B is equal to mu naught H. B is equal to mu naught H, 2 pi rho into a phi. Now we can get the magnetic flux, which is given as what? Surface integration of B dot ds is the magnetic flux now, tell me. So that means phi, which is given as surface integration of what I can say, B dot ds. B is what you tell me now here, mu naught I by 2 pi rho into a phi dot ds. This is the ds now, that is d rho d phi into a phi, right? So then from this flux is given as what you tell me, flux which is given as the surface integral of mu naught I by 2 pi rho into d rho into dz. Now let's do integrate now here, which is given as mu naught I by 2 pi is a constant, take outside. Now the rho limits are what you tell me here, 2 to 6. Rho limits are 2 to 6. This is 1 by rho into d rho. And what of z limits are what? 0 to 4 na into dz. So which is given as mu naught I by 2 pi into what I can say ln of 6 by 2 into z value is a 4. So the flux which is given as mu naught I by 2 pi into 4 into ln of 3. Done? Next one. A circular conductor placed in the xy plane. A circular conductor which is placed in the xy plane undergoes thermal expansion. Expansion means what now here? It is increasing while it is in uniform magnetic field. Okay, magnetic field is constant but area is increasing. A current will be induced in a clockwise around it. Then the direction of the magnetic field is. Now they are asking to find the direction of the magnetic field now. Right. Means, see this thing here. So let us call this is my xy plane. XY plane, a circular conductor. So this is due to thermal expansion, the area increases. Fine. Now what they are saying is a flow of current. Yes, they given that. So here current is induced in clockwise, means this is direction of current now here. And this is what current, you tell me, induced current. So we have this current, induced current. And what the direction of the induced current, you tell me? The direction of the induced current, which is clockwise directions. The direction of the induced current is what direction? Clockwise. By knowing the direction of current, can you find the direction of induced magnetic field? That is called a B induced. Can you tell me the direction of magnetic field? So current is a clockwise, so I can say this is the magnetic field is inside now here cross. This is x and y. Inside means what I can say now here, that is a negative z axis. That we can call this as a negative z directions. All of you inside now. Now what I need now, whose magnetic field? Induced magnetic field is required, original field is required. We need the original field is required, not the induced field, remember. We need the original field required. So here you see this thing carefully. Now here a current is induced in a clockwise direction. Here what happening here? Thermal expansion. Now thermal expansion current will increases. If the current increases, what the direction of the induced field is? Which is induced field and original field are opposite to each other now. Opposite to induced field, you tell me. Hana boliye this thing. So original field is what direction here? So induced field is negative z direction. So original field is what direction must be? This must be positive z directions. So means this is positive z direction. Okay. Option C. Next one. A magnetic field of B is given as like this. Okay, is applied to a rectangle loop of path which is given as, see the path what they given here. Now you can see the path now here. Which plane you see carefully. In this entire movement, which are constant you see carefully. Now if I call this is my y and z, so this x value completely constant if you see carefully. So this is a point of 0 0 0 and this is 0 1 0. So this point from here to here we have moved, and thereafter here this point yz value 1 1. Next thereafter it is moved to here, and thereafter it is moved to here. You see carefully. These are the points now here. So this means 0 0 0 0. This point is 0 1 0. This point is 0 1 1, and this is 0 0 1. And again this thing, this is a moment takes place. Y and z value, y value changes from 0 to 1, z value also changes from 0 to 1, right? Now can you tell me now here surface area of this loop, and which is given as what I can write now here, dy and dz, and direction is what direction now, positive x direction, outside anti-clockwise direction. Now you tell me now here, first to get the induced EMF, first we are finding the flux. We are finding flux is given as surface integration of what, b dot ds. Surface integration of what, b dot ds is my flux. Now tell me now here flux, that is surface integration of b value. So if I do this thing here, b dot ds we have taken, so tell me ax dot ax is 1, remaining terms will become 0 now. So which is given as, that is 2 into sine omega t into ax minus 2 into cos omega t into ay dot with what you tell me, dy dz into ax cap. So finally flux which is given as surface integration of 2 into sine omega t dy and dz. Okay, so now flux which is given as 2 sine omega t is a constant. Now the integration is with respect to y. Y limits are what, 0 to 1 into dy. Z limits, z is also 0 to 1, or limits are, z limits also 0 to 1. So what I'll get my flux, tell me, that is given as 2 sine omega t. This is my flux. If I know the flux, we can get EMF. So my induced EMF which is given as what you tell me, minus of d phi by dt, minus of d phi by dt. So from this we can say the EMF which is given as minus of, here we have, so 2 sine omega t. So this is what we'll get now here, that is 2 omega into cos omega t na. So that's why EMF, which I will get this as 2 into omega value 100 pi. So which we can say this as 200 pi into cos of omega t, right? So this is my induced EMF, and what they asking to find here, the peak value they asking to find. So what is the peak value, tell me now here, that is Vm. How much is Vm here? So we can say magnitude. How much you tell me now, which is equal to 200 pi. C is the magnitude of the induced EMF. Done. Right. So these are the 25 questions we have solved. I hope all of you understand this thing here. The most expected question we have discussed. This complete PDF I will share in the Telegram channel as well as in the community. You do follow me in the community and the Telegram channels. As I told you now, this short notes also you can able to utilize it. These are the short notes. You can see, have a look at here. We have prepared the short notes. It will cover all the topics in detailed manner. You can have a look at here. Each and every formula is covered in these short notes. Done. And these are the new batches we are starting. You can follow this new batches you can follow, and so you can to join this the Unacademy Plus, you can use a code of B V Reddy to avail this great offers. And so here I'm starting the digital electronics. I'm starting from the 18th of January at 5 o'clock. Fine. Yeah, that's for the today's class, and we'll meet in the next class. All of you do follow me. All of you do follow